my name is Nicholas Breitling, and the topic of my project is improving 3D fluid simulation performance using ray marching and a combined grid particle algorithm. As for some background information, performance is often a limiting factor in fluid simulation and can hinder opportunities for use in interactive media or other entertainment-oriented applications. And this is seen quite clearly in Lagrangian or particle-based techniques and Eulerian or grid-based techniques, which are two of the most common simulation techniques used today. Such as with Eulerian techniques, how each grid cell needs to check for all of its neighboring grid cells, which grows very costly at high grid resolutions. And with Lagrangian or particle-based techniques, each particle needs to iterate through all of its neighboring particles, which can cause similar computational costs. And another challenge is with the separation of simulation, mesh generation, and rendering into their own discrete steps, which are each very computationally costly. So the proposed solution to this problem is to actually combine Eulerian and Lagrangian techniques and have individual particles propagate their data to a grid using a 3-pass Gaussian blur algorithm, and then subsequently read from this grid to calculate motion. And the technique also implements ray march rendering, which further improves performance by eliminating the mesh generation step altogether, and instead allowing the simulation grid to be repurposed as an approximate sign distance field. So for the hypothesis, I predicted that the algorithm would yield lower rendering times as well as higher resolution shading when compared to a set of 3 control algorithms. Finally, for my experimental design, I first developed 2 rendering frameworks, one utilizing mesh rendering and one utilizing ray marching, and then subsequently developed 4 algorithms for comparison, including the 3 control algorithms outlined here, as well as the experimental algorithm outlined here. And then finally, I benchmarked each algorithm and collected data on their performance. So thank you for watching. That's it for my 2-minute presentation.